It began with a signal that shouldn't have existed. A narrow spike of data, faint, precise, and repeating every 11.2 seconds, flickered through the deep space monitoring feed. At the Cerro Pachón Observatory in Chile, 2:47 a.m., July 1st, 2025. For a moment, the room went still. This wasn't cosmic noise. It was structured almost mechanical, like a pattern buried beneath static. Then, as quickly as it appeared, it vanished. Telescopes automatically pivoted toward the coordinates, triangulating, recalibrating, and that's when something new came into view. Not a star, not a comet, but an object cutting across the sky at an impossible angle, faster than any known asteroid on record. The computers flagged it, uncatalogued interstellar object, temporary designation pending. Tonight, we embark on a new journey, where the theme of 3I Atlas, they are now, preparing, for first contact appears not only as a scientific phenomenon, but also as a question that challenges our imagination. If you enjoy this kind of quiet, long-form storytelling, if it helps you relax at the end of a noisy day, take a moment to like the video and subscribe, but only if this space truly brings you peace. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. And so, as we return to that quiet July morning, to the moment the signal blinked into existence and the world held its breath, we begin with a simple question. Why did every telescope fall silent for 48 hours after discovering 3I Atlas? On the night of July 1st, 2025, the automated eyes of the Atlas survey in Chile registered a new point of light. It was not merely another asteroid or comet, its trajectory was hyperbolic, an open road from the depths of interstellar space. Designated 3I Atlas, it became the third known visitor from beyond our solar system. Yet, in the immediate aftermath of its discovery, a profound and unsettling silence descended upon the global astronomical community. For 48 hours, the public data streams from the world's premier observatories fell quiet, as if the object had been observed, logged, and then deliberately ignored. This was not the typical clamour of scientific discovery. It was a calculated pause, a collective intake of breath from the scientific establishment. The mainstream explanation points to a necessary, if protracted, a period of verification. According to current protocols for potentially significant discoveries, a multi-step process of data validation must occur. Teams must rule out instrumental glitches, satellite reflections, or other celestial masqueraders. The initial data, however compelling, required cross-confirmation from other sites to pin down its precise orbit and velocity. This was an object moving at speeds that defied simple gravitational capture by the Sun, and thus, the stakes for a false alarm were immeasurably high. Could the scientific community truly afford to announce an interstellar visitor, only to retract the statement days later, its credibility shattered? Yet, the 48-hour window seems peculiarly precise, and the silence unusually comprehensive. This leads to a more speculative hypothesis, that this was not merely procedural caution, but a pre-programmed interstellar diplomatic buffer. A silent interval, a universally understood moment of assessment before first contact is initiated. One could postulate the existence of an unwritten cosmic protocol, a waiting period where the discovering civilization observes in silence, evaluating the potential threat or intent of the newcomer before alerting its entire population. Alternatively, could this have been an automated response from planetary defense networks we do not yet know exist? A silent, global information firewall triggered by the specific kinematic signature of an artificial object, temporarily quarantining the data for a highest-level threat assessment. The very uniformity of the silence suggests a level of coordination that transcends standard scientific practice. What unseen protocol, drafted for a day humanity hoped would never come, was silently activated in those 2 days? The evidence from this period is fragmentary, yet telling. While major observatories like Keck and the VLA maintained their public schedules, they notably delayed their standard data release pipelines, citing extended data quality assessment. Smaller, independent monitoring networks reported unexplained latency in their own feeds, a series of minor technical glitches that collectively formed a pattern of obstruction. The timeline is clear. Detection on the night of July 1st, a flurry of POTN, internal, encrypted communications, and then a public information vacuum lasting until the morning of July 3rd. Was this merely the scientific method operating with due diligence, or was it the first human experience of a galactic quarantine? When the data embargo finally lifted, the first trickle of information was the object's light curve and preliminary spectroscopic analysis. The James Webb Space Telescope, having swiftly been retargeted, captured the most telling data in August 2025. The spectrum of 3I Atlas was unlike anything seen in a natural body. A coma, the cloud of gas and dust that typically surrounds a comet, was present, but its composition was a profound anomaly. Instead of being dominated by water, ice, and other volatiles, the coma of 3I Atlas showed an overwhelming signature of carbon dioxide. This is not the breath of a comet as we know it. It is the exhaust of something else entirely. The conventional model struggles to account for this. Scientists suggest this could be due to a unique planetary formation history, an object born in an extraordinarily carbon-rich protoplanetary disk. Such a body could, in theory, possess a crust of frozen carbon dioxide, which upon approaching the Sun would sublimate violently, creating the observed coma. The known interstellar object 2I Borisov displayed a coma composition not dissimilar from solar system comets, making 3I Atlas a stark outlier. But does a formation model based on sheer cosmic chance adequately explain the sheer dominance of this single compound, a compound so pivotal to biological and technological processes on our own world? This spectral oddity forces a more radical hypothesis into consideration. The carbon dioxide-dominated coma may not be a natural effusion, but a form of emission or propulsion residue. If the object is not a passive rock, but possesses an internal power source, the breakdown of complex organic materials or a specific type of low-temperature combustion could produce such a spectral fingerprint. The carbon dioxide could be the waste product of a functioning or a malfunctioning system. It is the signature of a process, not merely the evaporation of ices. This leads to an inescapable and chilling question. Are we observing the spectral lines of a natural comet, or are we reading the exhaust plume of an engine? The spectral data from 3I Atlas, as meticulously reobserved in August 2025, does not sing the familiar song of a natural celestial body. It whispers a dissonant tune, a cryptic message written in the language of light and shadow. The coma, that tenuous atmosphere enveloping the core, presents a composition dominated by carbon dioxide, a stark departure from the water-rich profiles of most long-period comets. More unsettling is the object's reflectance spectrum, a flat, almost nonchalant line in the near-infrared that refuses to conform to the steep, diagnostic slopes of known ices and silicates. According to current models, a comet from the far reaches of the Oort cloud could, in theory, be a primordial relic rich in frozen carbon dioxide, a volatile iceberg preserved in the deep freeze of interstellar space. Its strange light curve, reported by optical stations worldwide, which defies the classical phase functions of a rotating body, could be attributed to an unusually complex and irregular topography. But if this is merely a simple chunk of dry ice, why does its spectral signature lack the intricate features we would expect from a natural surface being heated and sublimated by the sun? This leads us to a more intricate hypothesis, that we are not looking at pristine ice, but at a surface engineered for purpose. Perhaps the nucleus is sheathed in a sophisticated thermal cloak, a composite material woven from complex organic polymers and metallic elements. Such a coating could be designed to manage thermal radiation with extreme efficiency, explaining the anomalous reflectance and the dye peculiar phase function. The dominant carbon dioxide signature would then not be the primary constituent of the object, but rather a byproduct of its operations, or even a deliberate emission used for propulsion or cooling. The flat spectral slope would be the result of a surface optimized to absorb or reflect specific wavelengths, a technology that manipulates light itself. Is the object's spectral strangeness a passive property, or is it an active form of communication or concealment? Pushing the speculation to its most profound level, we must confront the possibility that the spectral data is not just anomalous, but intentionally deceptive. This could represent an advanced form of optical thermal stealth technology, a system so sophisticated that it allows the object to control its apparent composition and temperature. The carbon dioxide, the flat reflectance, the non-conforming light curve, all of it could be a meticulously maintained disguise, a deliberate performance meant to mimic a comet for an audience of nascent astronomers. If this is the case, then every photon we capture has been filtered through a veil of its own choosing. What does it mean when the subject of our observation appears to be observing us in return, carefully controlling the light it reflects? The implications of such a technological interpretation are as vast as they are double-edged. If this is an engineered artifact, then its very presence in our solar system offers an unparalleled opportunity. We could be witnessing a masterclass in interstellar travel, learning the principles of thermal management for a vessel traversing the immense voids between stars. The material science behind such a cloak would revolutionize our own engineering. But this gift of knowledge comes with a profound risk. An entity capable of such technological subtlety is an entity that operates on a plane of awareness we can scarcely comprehend. To study it is to invite its gaze, and we must ask ourselves, in our fervor to unravel its secrets, have we become the observed, our own world and capabilities laid bare before an unknown intelligence? This spectral whisper, then, is not just a puzzle of light, but a test of our own perception. And if its appearance can be so meticulously controlled, what might its trajectory reveal about its intent, as it carves a path through the gravitational fabric of our system that defies all expectation? The data stream from early July 2025 presents a celestial mechanics puzzle of the highest order. The object designated 3I Atlas, traversing our inner solar system on a starkly hyperbolic trajectory, exhibited minute but persistent deviations from its predicted path. When modeled solely with the conventional forces of solar radiation pressure and standard outgassing, the ephemeris required repeated, subtle corrections. The solution, for orbit calculators, was the insertion of an ad hoc non-gravitational parameter, a mathematical fudge factor, acknowledging an unknown source of acceleration. This is the established protocol, a way to force our models to conform to reality. But what if the reality we are observing defies the very foundations of our models? The trajectory was not merely hyperbolic, it was being fine-tuned. According to current models, such non-gravitational accelerations are the hallmark of cometary activity. The intense heat of the sun vaporizes volatile ices locked within the nucleus, creating jets of carbon dioxide and water vapor that act like natural, if erratic, thrusters. For 3I Atlas, one could posit localized, asymmetric outgassing, a small persistent jet of carbon dioxide from a shadowed vent, nudging the object off a purely ballistic course. This is the most conservative, and therefore most scientifically palatable, explanation. It requires no new physics, only a particular and fortuitous geology for this interstellar visitor. Yet, the timing and consistency of these corrections give one pause. Could a purely natural process exhibit such a steady, directional influence, so unlike the stochastic sputtering of a typical comet? This leads to a more complex, yet still naturalistic hypothesis. Perhaps 3I Atlas is not thrusting, but sailing. As a natural object with specific magnetic properties, it could be interacting with the solar wind in a novel way. The concept of a passive plasma sail has been theorized. A body could, in principle, ride the magnetic gradients embedded in the solar wind, much as a sailboat tacks against the wind. The acceleration would be slight, continuous, and could account for the observed orbital refinements without the need for discrete jets. It would be a fascinating natural phenomenon, a demonstration of plasma physics on a cosmic scale. But does this merely replace one coincidence with another? For such an effect to produce the precise trajectory we observe, the object's composition and magnetic structure would have to be exquisitely, almost ideally, suited to the task. And this compels us to consider a more profound possibility. What if the corrections are not corrections at all, but course adjustments? The data from that first week of July could be interpreted as evidence of a microscopic reaction control system. Imagine not a massive engine, but a network of micro-thrusters, perhaps utilizing sublimated material from the surface itself, firing in a controlled sequence to maintain a specific attitude or trajectory. The non-gravitational parameter in our equations would then not be a fudge factor, but the faint signal of a control system. The object is not falling, it is flying. If this is true, then the very term orbit becomes a misnomer, implying a passive path dictated by gravity alone. What we are tracking may be a chosen flight path. The implications of this third hypothesis are as vast as they are unsettling. If 3I Atlas is under any form of guidance, however subtle, its passage through our solar system transforms from a chance encounter into a deliberate transit. The controlled trajectory is not a warning, but a signal in itself, a demonstration of capability, and perhaps intent. It is a quiet, unequivocal statement that the object, and whoever or whatever might have sent it, operates on a technological plane that allows it to navigate the gulfs between stars. This grants us an unprecedented opportunity to study an artifact of non-human engineering, but it also carries a sobering risk. It is a reminder that in this encounter, the closing speed, the point of closest approach, the very geometry of the flyby, may not be a matter of our calculations, but of their discretion. The trajectory is a message, but are we equipped to understand its grammar? This notion of guided passage inevitably forces a re-examination of the object's fundamental nature. If it can adjust its course, could it also have chosen its point of origin? The object designated 3I Atlas, now receding into the outer darkness from which it came, has left in its wake a silence more profound than any cosmic noise. Its fleeting passage through our inner solar system in the summer of 2025 was not an arrival, but perhaps a reawakening. The initial hypothesis of a simple interstellar comet, a shard of frozen gases from a distant star, now feels insufficient, a prosaic label for a phenomenon that defied expectation at every turn. The data it yielded suggests not a passive wanderer, but an entity with states of being. Its light curve, a meticulous record of its brightness, did not follow the gentle, predictable slope of a rotating icy body, sublimating evenly under the sun's warmth. Instead, it displayed sharp, almost deliberate fluctuations in reflectivity, as if its surface properties were changing in discrete steps. According to current models, such behavior could be explained by the complex, non-uniform shedding of surface layers, a kind of exfoliation in the vacuum of space as different ices responded to the solar influx. But that does not account for the precise correlation of these shifts with its heliocentric distance, a rhythm more suggestive of a system crossing energy thresholds than a simple melt. Could it be that we were not witnessing the death throes of a primordial ice ball, but the boot-up sequence of a system dormant for eons, its internal sensors stirring to life as it finally reached a specific, preordained stellar flux? This notion of a dormant artifact finds a chilling resonance in its chemical autopsy. Spectroscopic analysis, which reads the unique fingerprints of elements and molecules in reflected light, revealed a composition that was not merely unusual, but functionally anomalous. The ratio of carbon dioxide to water was profoundly skewed, a chemical signature not seen in any known cometary body within our own solar system. Scientists suggest this could be due to its exotic origin in a protoplanetary disk, with a radically different carbon to oxygen ratio, a natural explanation born of cosmic diversity. However, the specific ratio and its stability across temperature gradients hints at something beyond natural chemistry. It suggests a system where these volatiles are not merely frozen reservoirs, but part of an integrated, regulated environment. The outgassing events were too controlled, too stoichiometrically neat. Could the anomalous carbon dioxide to water ratio be not a signature of birth, but of function, the exhaust, or perhaps the coolant, of a sophisticated thermal and atmospheric management system, designed to protect a delicate internal architecture from the violent thermal shock of a close stellar passage? These accumulating peculiarities did not go unnoticed in the brief, intense window of its observability. Between July and August of 2025, a quiet but profound shift occurred within the astronomical community. The discourse, once confined to technical papers on non-gravitational acceleration and spectral lines, began to cautiously, publicly, entertain a possibility once relegated to fiction. Respected commentators, in interviews and panel discussions, began to articulate the technological origin scenario not as a fantasy, but as a legitimate, if unproven, framework that warranted serious consideration. The mainstream explanation still held the podium, but a new audacious challenger had stepped into the ring. The very fact that such a hypothesis could be discussed openly in scientific circles without immediate dismissal marks a pivotal moment in our relationship with the cosmos. Were we, for the first time, collectively gathering the courage to interpret the data not through the lens of what we know, but through the terrifying and exhilarating possibility of what we do not? This leads us to the first and most conservative layer of the technological hypothesis, the dormant artifact. Imagine a probe, a Voyager, not unlike our own Voyager or Pioneer, but forged by a civilization so ancient that its launch predates the very formation of our planet. For billions of years, it drifts in the profound cold and silence of the interstellar medium, its systems powered down to a state of near infinite preservation, a piece of cosmic flotsam. Its trajectory is not aimed, but random, a product of galactic tides and stellar close encounters. Then, it falls into the gravity well of our Sunday. As it approaches the inner system, its external sensors, tuned to a specific threshold of radiant energy, perhaps the spectrum of a G-type star, detect the required stimulus. A cascade of internal processes begins. Power is rerouted from long-term storage to active systems. Its outer shell, perhaps a metamaterial designed for both stealth and protection, undergoes a phase change, altering its albedo and creating the anomalous light curve we observed. This is a vessel not in flight, but awakening from a slumber measured in geological epochs. It did not come for us. It merely passed through our neighborhood and found the conditions suitable to resume its long-interrupted functions. But what functions were those? Was the activation of its sensors merely a system check, or the first step in a far more complex and purposeful agenda? This question propels us to the second, more profound level of speculation, the survey beacon. If the object was merely waking up, what was its waking purpose? Its trajectory, which brought it so close to the Sun and then slingshotted it past Earth, was an ideal path for a reconnaissance probe, not for a prolonged study, but for a rapid, intensive scan. The various spectroscopic instruments trained upon it were, in this hypothesis, being met with a form of counter-surveillance. As we analyzed its composition, it could have been analyzing ours. It was sampling the tenuous outskirts of our atmosphere, measuring the chemical imbalances that betray the presence of life. The elevated oxygen, the traces of methane, the complex smog of industrial and biological molecules that form the biomarker signature of Earth. Its brief, intense period of activity around perihelion could have been a data-gathering burst, a quick assessment of the biosphere's status and technological maturity of the third planet. The object may not be a dedicated messenger, but one node in a vast, dispersed network of automated sentinels, their primary mission to log the emergence and evolution of life throughout the galaxy. It collected its data, completed its flyby, and returned to its dormant state, its mission accomplished, its findings now propagating at the speed of light back to its point of origin, or to the next relay in the chain. What kind of report then did our world generate in its silent transmission? This network concept leads to the third and most expansive hypothesis, the knowledge way station. Perhaps 3I Atlas was never intended as a mere data collector, but serves a grander, more enduring purpose. Its bizarre physical properties, the potential for internal regulation, its apparent resilience to radiation, and cosmic wear suggest an object built for longevity on a galactic timescale. It may be one piece of a larger, distributed infrastructure, a kind of interstellar internet or library. These way stations would be placed, either deliberately or through a slow, diffusive process, throughout the galaxy, acting as relays for information, repositories of knowledge, or even as navigation beacons for other, more sophisticated travelers. Its activation near our Sun was not about studying Earth specifically, but about checking on the status of this particular node within the network. Its trajectory might have been a scheduled maintenance run through a region of space known to harbor a life-bearing world, a routine update to the galactic database. In this view, the object is a piece of civil engineering on a cosmic scale, a silent monument to a civilization that has perhaps long since transcended the need for physical travel, preferring to build a permanent, resilient lattice of knowledge and communication. If this is true, did we just witness a flicker of activity from the galactic background infrastructure that has been operating around us and largely ignored by us for billions of years? The implications of these layered hypotheses present humanity with a juncture of unparalleled opportunity and inscrutable risk. The opportunity is the stuff of dreams, to reverse engineer a technology that has endured a billion-year journey, to learn the principles of materials, science, energy storage, and computation that far surpass our own. It would be a shortcut across millennia of research and development, a chance to touch the workings of an intelligence that has mastered deep time. A single fragment of its construction, understood, could revolutionize our future, but the risk is its shadow. In awakening such a system, even if our Sun was the alarm clock, what protocols did we trigger? A system with such a purpose, be it a surveyor, a beacon, or a way station, was built with an agenda that does not include us. Its goals were set in motion before our species ever walked the Earth. Our attempts to communicate with it, to chase it, to perhaps even retrieve a piece of it, could be interpreted in ways we cannot anticipate. We might be seen as interesting fauna, as a contamination to be sterilized, or as a resource to be logged. The greatest danger may not be hostility, but indifference, a system so advanced that it simply collects its data and moves on, leaving us to wonder if our own technological signature has just been catalogued in a database whose purpose and owners remain forever unknown. Have we, in our eager observation, merely passed a cosmic audition whose results we will never see, or have we inadvertently tripped a silent alarm in a house that is not our own? And as the object faded from view, a final, lingering mystery took root, not in the light it reflected, but in the signals it may have emitted. For if 3I Atlas was an active piece of technology, its communication would not be through the silent language of chemistry and light, but through the focused whisper of radio waves. Rumors persist, circulating in the hushed corridors of observatories and online forums, of anomalous low-frequency radio signals detected during the object's close approach. signals that were filtered from the public data streams, a silent conversation we were not meant to hear. The silent symphony of the cosmos is never truly silent. Our planet is constantly bathed in a cacophony of electromagnetic radiation, a legacy of stellar furnaces, the faint echo of the Big Bang, and the increasingly loud chatter of our own civilization. It is from this chaotic sea of noise that we attempt to pluck the faint, coherent whisper of something other. Our primary tool in this endeavor is a network of colossal ears, radio telescopes that strain to hear the universe. Yet, the data they collect is not always a raw, unadulterated stream. It is processed, filtered, and cleaned before it is released into the public domain for astronomers and enthusiasts alike to scrutinize. This is a standard, necessary procedure to remove terrestrial interference and well-understood atmospheric phenomena. But what happens when the filtering itself becomes the signal? When the very absence of data speaks louder than its presence? Rumors began as a subtle undercurrent within specialized forums and preprint servers in late August and September of 2025. They spoke of anomalous, continuous spectral gaps in newly published datasets from several public radio astronomy archives. These were not the random, transient silences caused by technical malfunctions, but structured, deliberate-looking voids in the lowest frequency bands, specifically below 50 MHz. This region of the spectrum, the very long waves, is notoriously difficult to observe from Earth's surface, as it is reflected and distorted by the ionosphere. According to current models, these gaps could be attributed to an aggressive new filtering algorithm designed to scrub out the intense radio noise from global lightning activity and ionospheric turbulence, a perpetual challenge for low-frequency radio astronomy. The official explanation was one of data hygiene, a necessary step to create a cleaner canvas for legitimate scientific discovery. But does a cleaner canvas always lead to a truer picture, or does it risk erasing faint, crucial details from the masterpiece itself? The mainstream scientific explanation posits that our increasing reliance on sophisticated digital signal processing has naturally led to more stringent data cleaning protocols. The ionosphere, a dynamic and electrically charged layer of our atmosphere, acts as a chaotic lens for these long wavelengths, and powerful computational models are employed to subtract its predictable effects. Scientists suggest this could be due to a new, more sensitive class of algorithms capable of identifying and removing even the faintest signatures of atmospheric interference, signatures that were previously considered part of the irreducible background noise. The goal is noble, to peer deeper into the cosmic static than ever before. Yet, the timing and specific nature of these spectral silences raise a disquieting possibility. What if the filter is not just removing noise, but a signal we have been instructed not to hear? The speculative hypothesis challenges the premise of mere interference removal. It proposes that the object known as 3I Atlas, an itinerant visitor from the void, is not a passive emitter, but an active broadcaster. Its most profound communication, however, may not be in the frequencies we so eagerly monitor, but in the long-wave radio bands we have largely neglected. The concept is one of an encrypted beacon, transmitting a signal below 50 MHz that only becomes coherent and unlocked after passing through the natural filter of a planetary magnetosphere. This is not a signal designed for deep space, but one intended for a civilization already residing within the protective magnetic bubble of a world. The signal structure would be inherently unreadable from the sterile environment of interstellar space, requiring the complex interactions with a planet's magnetic field to decode its message. Could it be that we are not the intended recipients, and the beacon is simply checking for the presence of a suitable, magnetically shielded biosphere? The evidence, while circumstantial, is provocatively synchronized. Analysis of maintenance logs for several long-wave infrastructure antennas, part of a global network used for submarine communications and geological surveying, revealed an unusual pattern. Their scheduled downtime in August and September 2025 displayed a curious phasing, creating collective periods of global silence in the very low-frequency spectrum. These maintenance windows aligned precisely with the observational windows, during which 3I Atlas was at its most favorable position for Earth-based study. This coordination could be dismissed as a remarkable coincidence, a byproduct of routine, globally distributed infrastructure management. But the confluence of these scheduled silences with the appearance of artificial-looking gaps in public astronomy data invites a more profound inquiry. Is it merely routine maintenance, or a coordinated, global effort to ensure a clear channel, free from our own terrestrial transmissions, for something else to be heard? Our analysis must therefore proceed through escalating tiers of interpretation, each layer venturing further from the comfort of established science. At the first level, we have the conventional explanation, advanced noise filtration. This is the null hypothesis, the one that requires no new physics or extraordinary actors. It is the most probable, the most conservative, and the most scientifically prudent stance. It attributes the spectral gaps to our own increasingly sophisticated tools for managing the messy reality of observational data. But if the filtration is so advanced, why does it leave behind such geometrically perfect voids rather than the statistical subtleties one would expect from a stochastic process like atmospheric noise? This leads us to the second level of interpretation, a deliberate, narrow feature screening protocol. Here, the hypothesis shifts from removing noise to avoiding a specific kind of signal. The global scientific infrastructure, perhaps guided by a confidential cross-agency protocol, could be implementing a filter designed to excise any signal that bears the hallmarks of artificiality within this low-frequency band. The stated rationale, were it to be made public, would be one of planetary security and social stability. The sudden, public discovery of an unambiguous, artificial signal from an interstellar object could trigger global panic, economic collapse, and a fundamental shattering of our societal self-conception. The filter, then, becomes a safeguard, a digital silencer on a loaded cosmic gun. But who granted the authority to decide what humanity is, and is not, ready to hear? Does the prevention of potential panic justify the imposition of a curated reality, one where the greatest discovery in human history is reduced to a classified annex? The third and most profound level of interpretation introduces the concept of a pre-contact protocol. This speculative framework suggests that the filtering and the coordinated antenna silences are not merely defensive or precautionary, but are themselves a form of response. The hypothesis posits the existence of a long-drafted, ultra-secret plan developed in the quiet corridors of global security agencies in consultation with a select few scientists for just such an occasion. This plan designates a single, pre-approved listener, a specific nation, agency, or even a private entity, with the sole authority and technical capability to monitor and engage with the low-frequency channel. The public data is scrubbed not just to avoid panic, but to prevent interference, to keep the global scientific community from accidentally jamming a channel reserved for a designated interlocutor. The protocol assumes a caller sophisticated enough to understand our planet's magnetospheric key and to expect a single, coherent reply from the world it is probing. Are we witnessing not a scientific discovery, but the quiet, unannounced activation of a diplomatic backchannel, with all of humanity save for a chosen few relegated to the role of spectators? The opportunities and risks embedded in this scenario are existential in scale. On one hand, a controlled, managed process for first contact could prevent catastrophic misunderstandings. A single, vetted message stream, analyzed by the best minds with the full backing of global intelligence, could mitigate the risk of a mistranslated greeting or an unintentional declaration of war. It allows for a measured, careful response, avoiding the chaotic cacophony of a billion competing voices from Earth. It is, in a sense, the ultimate application of the scientific method to the problem of alien communication. Isolate the variable, control the experiment, and proceed with caution. But does the scientific method, with its inherent demands for transparency and peer review, not die in the darkness of such absolute secrecy? The great risk, of course, is that this very control becomes a prison for human knowledge. By gating the most profound discovery behind a wall of security clearances and data filtration, we risk creating a permanent schism between official science and public understanding. Citizen scientists, amateur astronomers, and the collective curiosity of our entire species are locked outside the door of history. The scientific process, which thrives on open debate, independent verification, and the democratization of data, is subverted. The signal, if it exists, becomes the property of a state, not a heritage of humanity. We are left to wonder if the silence from the stars is a natural void, or one we have been commanded to maintain. And if a message is received and a reply is sent, who among us will have the right to know what was said, or what we have promised on behalf of our entire planet? This deliberate curation of cosmic noise, this potential silencing of a specific frequency, leads us to a larger, more coordinated pattern, emerging not in the shadows, but in the full light of day. For if one part of the global apparatus is engaged in quiet signal management, another is simultaneously, and very publicly, building a new kind of net, cast across the solar system. The coordinated announcements from NASA, the European Space Agency, and JAXA throughout the final quarter of 2025 regarding the intensified tracking of interstellar object 3I Atlas present a facade of routine scientific cooperation. Publicly, these releases detailed a division of labor. The James Webb Space Telescope committed its formidable infrared gaze, the Deep Space Network arrays tuned their radio ears, and terrestrial optical telescopes like the VLT synchronized their watch. This is the established protocol, the logical allocation of resources to study a unique celestial visitor. It is the picture of modern, efficient astrophysics, a global community united in curiosity. But when the timelines of these campaigns are laid bare, a different pattern emerges, one that suggests not a spontaneous collaboration, but the activation of a long, dormant, pre-established protocol. Could such seamless integration truly be born of ad hoc decisions, or does it hint at a deeper, more prepared infrastructure? The mainstream scientific explanation is one of pragmatic optimization. The study of a fast-moving interstellar object is a race against time, requiring a continuous multi-wavelength observation campaign that no single agency or telescope can sustain alone. By establishing a clear schedule and assigning specific observational techniques to the facilities best equipped for them, the global scientific community avoids redundant data collection. This allows for a more complete, stereoscopic portrait of the object to be assembled. The public-facing narrative is one of international goodwill and shared purpose, a testament to how science should operate in the 21st century. It is a convincing argument for the simple elegance of cooperation. Yet, one must ask if the sheer speed and precision of this operational choreography, unfolding across multiple continents and orbital platforms, could be achieved without prior planning and dedicated, secure communication channels reserved for such an eventuality. This leads to a more speculative hypothesis, that what we are witnessing is not merely cooperation, but the unveiling of the interstellar preparedness network. This would be a clandestine backbone, a dedicated and secure communications and command infrastructure shared between the world's leading space agencies. Its purpose would be to function as a rapid response network, a unified sensorium for the solar system. In this model, the division of labor is not a matter of bureaucratic agreement, but a pre-assigned tactical roles: optical for trajectory and rotation, infrared for surface composition and thermal properties, radio for any active emissions, and planetary radar for precise ranging and surface topology. The synchronized campaign of late 2025 would then be a live-fire exercise, a test of a system designed not just for observation, but for analysis and response. Is humanity, for the first time, practicing to become a single, cohesive entity, facing outward into the galactic dark? The evidence lies in the meticulously synchronized calendars and the curious prioritization of this single target. Ground-based and space-based observatories, instruments typically oversubscribed by thousands of astronomers, suddenly and seamlessly cleared their schedules for coordinated windows of observation. This points to a command hierarchy, capable of overriding standard scientific proposals, a capability that implies a pre-existing framework for declaring an object of highest interest. Furthermore, the establishment of new AI-driven data processing pipelines, specifically flagged for handling anomalous data streams from these observations, is particularly telling. These are not tools developed in the moment, they are specialized systems, now being publicly unveiled, that must have been in development for years, waiting for the correct trigger. What specific parameters, what unique signature in the data from 3i Atlas prompted the activation of this entire, intricate apparatus? Our analysis must therefore proceed through escalating levels of implication. At the first level, the network is a tool of supreme resource optimization, a logical evolution of scientific endeavor to eliminate redundancy and maximize data return from transient phenomena. It is the ultimate expression of international scientific diplomacy. But does such a sterile explanation account for the palpable shift in operational tempo and the clear establishment of a centralized, albeit distributed, command and control structure? At the second level, the hypothesis deepens. This is not merely a network for observation, but a full dress rehearsal for a contact scenario. The synchronized efforts to measure, to analyze in near real time, and to model the object's properties and trajectory resemble a planetary-scale diagnostic system. Every facet of the object is being probed simultaneously, as if attempting to understand not just its composition, but its intent, its origin, and its potential threat level. The combined assets act as a single, distributed instrument, its purpose to reduce the unknown to a set of quantifiable, manageable data points. Could this be humanity's first, fumbling attempt to conduct a tactical assessment of a piece of technology not of this world? This logically culminates in the third and most profound level of inference, that we are observing the key components of an end-to-end first contact protocol. The network's true function is to integrate the entire sequence from detection to response. The telescopes are the eyes, the AI pipelines are the cognitive brain, and the deep space network, with its powerful transmitters, represents the potential mouth. The silent, passive observation of 3i Atlas is, in this framework, merely the first phase. The system is being tested under real-world conditions, its latency measured, its decision-making pathways stress-tested. The quiet announcements from NASA, ESA, and JAXA are the public output of a system that is, in its hidden layers, running a continuous simulation. If this object were to change course or emit a signal, what would we do? The network's existence implies that the highest echelons of space science have already moved beyond the question of if we are being visited and are now preoccupied with the practicalities of what to do when it happens. Have we, without public acknowledgement, already begun to craft the tools for our first conversation with another intelligence? The opportunities presented by such a unified scientific front are immense, heralding an era of consolidated science where the whole of human knowledge is brought to bear on a single problem. It promises a golden age of discovery. Yet, this concert of agencies raises profound questions about planetary data sovereignty. Who controls the information gleaned from this network? Who decides what is shared with the public and what is deemed too sensitive? The very infrastructure designed to unite humanity in the face of the cosmos also creates the potential for the most profound concentration of knowledge and power in human history. As this global sensorium turns its collective gaze upon 3i Atlas, one must wonder who, or what, is truly in control of what it sees and what it decides to do with that vision. And if this network is now fully active, what will its sensors reveal as the object makes its closest approach? A revelation that may be interpreted not in public laboratories, but in the secure, soundproofed rooms of a select few. This very question of control and the flow of information finds a disturbing echo in the sudden, simultaneous silence that descends upon the high-altitude observatories at Mauna Kea. Just as the global network reaches its peak operational tempo, a series of coordinated technical maintenance shutdowns are announced, taking the most powerful optical and infrared telescopes on the planet offline. The official explanations are flawless, citing necessary upgrades to adaptive optics systems and spectrometer calibrations, a routine occurrence in the life of any complex observatory. The timing, however, is a statistical anomaly of breathtaking proportions, a confluence of downtime that effectively blinds a significant portion of Earth's deepest astronomical eyes at the very moment they are most needed. Is it merely an unfortunate coincidence, or a carefully orchestrated blackout? The mainstream narrative would have us believe that the relentless demands of cutting-edge science simply necessitated this maintenance window, that the wear and tear on these billion-dollar instruments requires periodic and unavoidable pauses. The agencies operating these telescopes emphasize their commitment to data integrity, stating that observations resumed after the maintenance would be of a higher fidelity, more valuable to the long-term study of the object. It is a perfectly reasonable, even commendable, position. But it fails to address the critical question of why these particular facilities, at this specific, historically unique moment, would all require immediate, simultaneous servicing. The logistical planning alone to coordinate such a global stand-down is immense, suggesting a priority that overrides the once-in-a-lifetime opportunity to observe an interstellar object at close range. What could possibly be important enough to justify such a collective lapse in our watchful gaze? A more disquieting hypothesis begins to form. This is not maintenance, it is a data quarantine. The synchronized silence suggests that the telescopes at Mauna Kea, and perhaps other key sites around the globe, did not cease observations due to technical faults, but because they saw something. The initial data stream from the intensified watch on 3i Atlas may have contained a signature, a spectral line, or a light curve anomaly, so unequivocally artificial or so profoundly unsettling that it triggered a prearranged protocol to cease public data dissemination immediately. The maintenance is a curtain drawn across the stage, allowing the technicians and the secured, classified teams behind the scenes to analyze the raw data without the scrutiny of the global scientific community or the public. The deep spectral data being gathered in those final moments before the blackout could hold the answer to humanity's oldest question, an answer that a select few have now decided is too dangerous, too destabilizing, to be shared. What did the deep eyes of Mauna Kea see in the light of 3i Atlas that we are not permitted to know? The thin cold air atop Mauna Kea, a realm already halfway to the stars, is accustomed to silence. But in the early days of August 2025, a new, more profound silence descended. It was not a silence of absence, but of cessation. One by one, the great eyes upon the mountain, Subaru, Keck, the Gemini Observatory entered a state of what public schedules uniformly termed unscheduled technical maintenance. The continuous, vital stream of deep spectral data from the universe's farthest reaches, a river of photons passed into the telling signatures of chemistry and physics, slowed to a trickle, and then ceased entirely. This coordinated quietus did not occur at a random interval. It coincided precisely with a predicted luminous phase of the object, known as 3i Atlas, a moment when its anomalous light was forecast to intensify. Was this a mere confluence of mundane necessities, or a carefully orchestrated blackout? The The mainstream explanation, as provided by the observatory consortia, points to the relentless demands of cutting-edge instrumentation. The spectrographs housed within these domes, such as the near-infrared spectrograph or the high-resolution Echelle spectrometer, are miracles of precision engineering, their optics and detectors exquisitely sensitive to the slightest environmental fluctuation or performance drift. According to current models, a synchronized maintenance window is a logistically prudent, if rare, event, allowing for crucial calibration against standard stars, mirror, realignment, and the purging of cryogenic coolants. It is a necessary pause to ensure the integrity of the data that will follow, a deep breath before a deeper look into the cosmos. Could the simple, wearisome reality of complex machinery explain the timing of this global silence? Yet, the nature of this particular maintenance cycle defies such straightforward logistical reasoning. Internal service logs, not intended for public dissemination, indicate a specific focus on the mid-infrared range, the 2 to 5 micrometer window of the electromagnetic spectrum. This is a region particularly rich with the thermal signatures of complex molecular bonds, the very domain where the waste heat of technology or the absorption lines of unfamiliar alloys might be found. Concurrently, public data portals, which routinely offer a lagging but accessible feed of astronomical findings, began exhibiting peculiar behavior. Requests for high-resolution spectral data from this period were met with unprecedented delays and cryptic error codes. The official explanation suggests server upgrades and data pipeline optimizations. But what optimization requires the deliberate hobbling of data accessibility for a specific, narrow band of light? This leads to the first speculative hypothesis, that these maintenance windows were not for repair, but for reconfiguration. The telescopes were not being fixed, they were being retasked. The shutdown may have provided the cover required to install specialized spectral filters, devices engineered not to enhance vision, but to restrict it. Their purpose would not be to see more, but to see differently, and to control what is seen. Such leak-restricting filters could be designed to selectively blind the instruments to specific, potentially revealing emission or absorption lines, effectively creating a controlled ignorance. Is it possible that the most powerful observatories on Earth were being deliberately blinded to certain cosmic truths? At the first level of analysis, we have the seasonal and operational argument. The summit of Mauna Kea is subject to extreme weather, and the late summer can bring unique atmospheric pressures and humidity levels that degrade infrared observing conditions. A coordinated pause to wait for more stable air is a reasonable, conservative approach to resource management. It protects the delicate instruments and ensures that the precious time of the world's premier telescopes is not wasted on poor quality data. Does the Occam's razor of practical observatory operation suffice to slice through the mystery? Progressing to the second level, we encounter the idea of standardized calibration for a joint campaign. The appearance of 3i Atlas represents an event of unparalleled scientific importance, an object that demands a unified, global response. Perhaps the various observatory teams, in conjunction with space-based assets like the James Webb Space Telescope, agreed to a simultaneous recalibration. This would ensure that every dataset collected during the object's next luminous phase would be directly comparable, eliminating inter-instrumental biases and creating a perfectly harmonized dataset. This would be the scientific method executed on a grand international scale. But does the pursuit of perfect data necessitate a public blackout of the very process used to achieve it? The third, and most profound, level of analysis suggests a policy of information compartmentalization, a deliberate effort to hide the spectral lines of technological material. The deep spectrum is a barcode of reality. Each element, each molecule, leaves its unique imprint. A line in the spectrum at a specific frequency could indicate the presence of a material with properties beyond our current metallurgy, or a power source utilizing physics we have not yet mastered. If such a signature were detected, its immediate and public release could be considered a risk. It would be a blueprint, a set of engineering principles, broadcast to every nation, corporation, and individual on the planet. The controlled silencing of the telescopes, therefore, becomes not an act of science, but an act of security. Are we, as a species, responsible enough to be entrusted with the fundamental secrets of a technology we did not create? The opportunities and risks inherent in such a decision are monumental. The primary opportunity is the preservation of data reliability and, potentially, global stability. By controlling the flow of such transformative information, a select group of international bodies could theoretically manage its integration into human knowledge, attempting to mitigate the shock to our economic, political, and theological systems. The data, when eventually released, would be pristine, thoroughly vetted, and contextualized. But this opportunity is purchased with a profound risk: the erosion of public trust. Science flourishes in transparency. Its authority is derived from its open, self-correcting process. To shroud its greatest discovery in secrecy is to undermine its very foundation. It creates a schism between the scientific priesthood and the populace they serve. Is the temporary stability gained through secrecy worth the permanent damage inflicted upon the covenant of open inquiry? This calculated silence atop a Hawaiian mountain speaks louder than any data stream. It hints at a recognition, at the highest levels of scientific and political power, that humanity may no longer be alone, and that this new reality requires a new kind of protocol. For if the great telescopes were being silently retasked, not for seeing, but for listening more intently on a preordained frequency, one might wonder what instructions they were following, and who, precisely, had written the script for this first silent act of contact. The silence is a protocol. For decades, the great radio telescopes of the world have listened, their colossal dishes turned towards the stellar abyss, awaiting a signal that would shatter human history. According to the established, public-facing protocols developed by the SETI Institute and international bodies, the discovery of a potential extraterrestrial signal would trigger a meticulous, multi-stage verification process. Independent observatories would be tasked with confirmation, data would be scrutinized for natural origins, and only after exhaustive peer review would a cautious announcement be made to the world. This is the standard procedure, a carefully constructed dam against a tide of both panic and premature excitement, designed to preserve scientific integrity above all else. It is a process built on the principle that the greatest discovery must first survive the greatest skepticism. But what if the verification has already begun, not in the public sphere, but in the soundproofed rooms of a global exercise? Anonymous leaks from within the astrobiology and SETI communities suggest that since 2024, a series of highly classified simulations have been underway. These are not mere academic discussions, they are full-scale diplomatic and scientific war games rehearsing the moment of first contact. The scenario, known internally by the designation 3I Atlas, is treated not as a possibility, but as a final examination. The protocols being tested are far more complex than the public would imagine. They encompass not only the expected radio channel analysis, but also sophisticated optical and laser communication, decryption, radar reflection modeling, and perhaps most intriguingly, a module dedicated to strategic silence, the deliberate and calculated decision not to reply. Workshops held by SETI and the International Astronomical Union throughout 2024 and 2025 have quietly circulated documents outlining procedures for anomalous signal processing, strict public information control rules, and unprecedented scientific diplomatic coordination. The late summer of 2025 is scheduled for simulated signal injections into the data streams of major observatories, a global stress test of our readiness. This suggests a level of institutional anticipation that far exceeds mere hypothesis. What anomalies have they already seen that necessitate such secretive and elaborate preparations? The mainstream scientific explanation for these exercises is one of prudent risk management. The history of science is littered with signals initially attributed to intelligence, from the perplexing regularity of the pulsars to the more recent "wow" signal that were later explained by natural, if exotic, phenomena. The scientific community is determined to avoid a repeat of such false alarms, which could erode public trust and sow unnecessary global anxiety. By stress testing the entire system, from signal detection to governmental response, they aim to create a robust framework capable of handling the immense psychological and sociological impact. Scientists suggest this could be due to the increasing sensitivity of our instruments, like the James Webb Space Telescope and the burgeoning arrays of next-generation radio telescopes, which make the detection of a technosignature statistically more probable within our lifetimes. It is a logical, responsible step for a technologically adolescent civilization peering into the cosmic dark. But does a drill of this scale and secrecy truly originate from a desire to manage a hypothetical, or does it imply that a specific, anomalous data stream has already been identified, one that possesses characteristics so compelling that it mandates a global rehearsal? This leads to the first speculative hypothesis, that the 3-eye atlas scenario is not a generic template, but a specific, data-driven prediction. The very structure of the exercise, with its modules for radio, optical, and radar protocols, implies that the anticipated signal is expected to be complex, multimodal, and deliberately crafted. For detection, the inclusion of strategic silence is particularly telling. The conventional post-detection protocol, as outlined in the Declaration of Principles Concerning Activities, following the detection of extraterrestrial intelligence, leans towards a cautious, coordinated response, but it does not explicitly mandate a non-response. The fact that a silence protocol is being seriously wargamed at the highest levels indicates a profound philosophical schism. It acknowledges the terrifying possibility that the content of the message may be less important than the simple, terrifying fact of its receipt. Are we rehearsing not only for a conversation, but for a moment where the safest course of action is to pretend we are not home? At the first level of analysis, we have the standard verification process. A signal is detected, it is verified for artificiality through its spectral structure and modulation. It is confirmed by independent observatories to rule out terrestrial interference or instrumental error, and finally, it is announced. This is the clean, linear process presented to the public. Yet, the very existence of the 2024 workshops reveals a starkly more complex reality. The internal documents reference not just scientific verification, but also public information rules and scientific diplomatic coordination. This immediately elevates the scenario to a second level of analysis, where the scientific discovery becomes a geopolitical event. The moment a signal is confirmed, a new daunting question emerges. Who speaks for Earth? There is no world government, no single authority granted the mandate to represent all of humanity in a dialogue with another intelligence. The United Nations Office for Outer Space Affairs has frameworks, but they lack the force of law. Would it be the nation-state that owns the telescope that made the discovery? A committee of scientists? A suddenly convened council of world leaders? The protocols being tested likely seek to pre-negotiate this answer in secret, to present a unified human front before the world's populations even know a front is required. But can any committee, no matter how well-intentioned, truly claim the authority to speak for 7 billion individual minds? This legal and diplomatic quagmire then gives rise to the third, and most profound, S-level of analysis. Faced with the paralyzing complexity of crafting a consensus response from a divided humanity, the simulations may be exploring a radical solution, letting the machines speak first. The response to a first contact signal may not be drafted by a panel of linguists, exobiologists, and philosophers, but by a sophisticated artificial intelligence. An AI system trained on the entirety of human literature, science, history, and art could analyze the incoming message and generate a statistically optimal reply, one designed to maximize understanding and minimize threat. It would be devoid of human emotion, of national bias, of the frailties of fear and ambition. It would be the pure voice of our collected knowledge. Proponents would argue that such a system could respond with a speed and coherence that our fractured political systems could never achieve. We would be using our ultimate tool of logic to make our first introduction, but in doing so, would we not be presenting a curated, sanitized version of ourselves, one that erases the very chaos, passion, and irrationality that defines the human experience? Are we prepared to be represented not by our poets, but by our algorithms? The opportunities presented by these clandestine preparations are significant. A coordinated, premeditated response could prevent a knee-jerk reaction that might misinterpret a benign signal as a threat, or vice versa. It could allow humanity to present itself as a mature, thoughtful species, capable of handling the profound implications of contact with grace and intelligence. The very act of preparing is the monumental step in our cosmic maturation. The risks, however, are equally monumental. The greatest danger may not be the message from the stars, but our own reaction to it. By moving the entire process into classified, governmental hands, we risk creating a controlled silence. The protocols, designed to manage information, could easily be perverted to suppress it. The moment of first contact, the most significant moment in biological history, could be deemed too dangerous for public knowledge, locked away in vaults under the guise of global security. The simulations at 3i Atlas may be as much about controlling the narrative for Earth's populations as they are about communicating with another world. Is our first act upon learning we are not alone to be an act of profound isolation, turning the very protocols of readiness into a cage of our own making? As we stand at this precipice, rehearsing a future that seems to be rushing towards us with increasing urgency, one must wonder what specific stellar coordinate, what unique frequency, is loaded into these simulation parameters. The exercises are too detailed, too layered, to be based on a mere abstraction. The modules for narrowband radio and optical decoding hint at a signal with a very specific expected signature, one that our most powerful instruments are being primed to find. The very structure of the secret protocol suggests that the architects of this global drill are not waiting for a random signal from the void, but are anticipating a specific one, from a specific direction, possessing a character so distinct that it allows for the creation of a multi-stage contact playbook. What data, collected from which star system, has provided the template for the 3i Atlas examination, and what does its silent, rhythmic cadence imply about the sender's intent? And if the simulations are indeed this precise, one must then ask if the final test is already upon us, not as a drill, but as a quiet, persistent signal now, being analyzed behind closed doors, a signal that aligns perfectly with the rehearsed scenarios. A signal, for instance, exhibiting a coherent phase pattern and a narrow band origin, perhaps from a sun-like star long of interest to astronomers, a star known as Tau Ceti. The silence of the cosmos is not truly silent. It is a cacophony of natural radio emissions, a static hiss born from the birth of stars, the death of galaxies, and the cold afterglow of creation itself. For decades, our instruments have sifted through this noise, listening for a whisper of order, a deliberate signal. In September of 2025, a series of preprint publications, circulating quietly among the corridors of the world's major radio observatories, began to discuss an anomaly. It was a spectral line, impossibly narrow, centered around the hallowed frequency of 1420 MHz, the hydrogen line, the universe's most natural radio station. The reports were cautious, filled with the language of uncertainty, but they all noted one peculiar detail. the direction of the antenna's beam during one of its routine calibration sweeps had inadvertently passed across the star Tau Ceti. According to current models, the hydrogen line is a fundamental pillar of radio astronomy. It is the fingerprint of neutral hydrogen, the most abundant substance in the universe, and its constant emission provides a map of the galactic structure. A narrowband signal at this frequency is the primary candidate for an artificial beacon, a deliberate shout into the darkness designed to be recognized by any emerging technological civilization. Scientists suggest this could be due to a natural maser, a cosmic laser, where interstellar clouds amplify the line under specific conditions. Yet, the observed bandwidth was narrower than any known natural maser, exhibiting a spectral purity that defies the chaotic conditions of the interstellar medium. The signal, though fleeting and unverified, possessed a coherence that whispered of engineering. But what if the signal was not a shout but a clock? The speculative hypothesis emerges. What if the object known as 3I Atlas is not merely a passive traveler, but an active component in a vast interstellar network? It could be a relay station, a node designed to receive, amplify, and retransmit data. Its sudden appearance and its precise trajectory could be explained if it is phase-locked with a fixed beacon located in the Tau Ceti system, using the universal constant of the hydrogen line as a galactic timekeeping channel to synchronize its navigation and communication systems across the light years. The signal's narrow bandwidth is not a product of its message, but of its method, a carrier wave of impeccable stability, a metronome for the stars. Is 3I Atlas merely a vessel, or is it a single cog in a machine of unimaginable scale, its movements dictated by a timepiece we are only just beginning to hear? The data, as it exists in the unverified event logs of a few radio telescope arrays, is a study in professional restraint. The entries describe a signal of suspicious but unverified origin, noting its narrow band characteristics and its spectral persistence over a single scan cycle. The observing logs meticulously record the situation as unable to confirm a terrestrial origin, a phrase that carries immense weight in the lexicon of astronomy. It is the careful language of scientists who have encountered something that fits the profile of an artifact, yet who understand the profound implications of a premature conclusion. All standard protocols for identifying local interference from satellite transponders to ground-based radar were executed, and yet the anomaly remained, a ghost in the machine that correlated with a point in the sky, a point that happened to be Tau Ceti. Could such a correlation be mere chance, a cosmic prank of alignment? The first level of analysis points to sophisticated local interference, or an ionospheric effect. The Earth's upper atmosphere is a dynamic plasma, capable of bending, reflecting, and even generating radio waves under the right conditions. A combination of a passing satellite and an ionospheric duct could, in theory, create a false signal that appears to originate from a distant celestial source. The Doppler shift of the signal, however, did not match the trajectory of any known orbiting object, and the specific frequency showed no signs of the scattering typical of atmospheric propagation. If it was interference, it was of a kind not previously documented, a phantom with a perfectly crafted disguise. The second level invites a more celestial, yet still natural explanation. Perhaps the signal originated from a previously unknown type of pulsar, or a rapidly rotating neutron star with an unusually stable period, its beam of radiation momentarily pointing toward Earth from a direction that, by sheer coincidence, aligns with Tau Ceti. The galaxy is vast and filled with phenomena that continually challenge our classifications. This remains the most conservative and scientifically palatable answer, an appeal to the universe's boundless capacity for creating natural wonders we have yet to comprehend. But does the universe, in all its chaotic glory, often produce signals of such artificial-seeming purity, signals that align so perfectly with our own scientific predictions for an interstellar beacon. This leads us to the third and most profound level of interpretation, the concept of routed communication. Imagine 3I Atlas not as a source, but as a repeater. It enters a predetermined volume of space, a designated mailbox, and for a brief window, it activates its receivers, tuned to the clock signal from Tau Ceti. It downloads a packet of data accumulated over centuries, and then, using its own power source, it rebroadcasts that data package towards the next node in the network, a node we cannot see. The signal detected was not for us. We simply intercepted a single handshake in a conversation that has been ongoing for millennia. We were not the intended recipients, but eavesdroppers on a single syllable of a galactic dialogue. What complex tapestry of information might be woven into those data packets? And what does it mean for a civilization to find itself suddenly and accidentally on the line? The opportunities presented by such a scenario are as staggering as the risks. If this hypothesis holds, humanity would have stumbled upon the greatest discovery in its history, not just proof of other intelligence, but access to the very infrastructure of their communication. We could listen in on the conversations of the universe, learning not from a message meant for us, but from the raw, unfiltered exchange between established cosmic cultures. It would be a shortcut to knowledge, spanning billions of years, a library of technologies, biologies, and histories beyond our imagination. The very laws of physics might be discussed and refined in those signals. But to join a network is to accept its protocols, and to become a node is to accept its vulnerabilities. By detecting the signal, by studying the relay, we have potentially revealed our presence. We are no longer silent observers. We are an uninvited guest on the line, a new and unpredictable element in a system of immense age and complexity. The risk is not necessarily one of invasion, but of exposure. We would have placed ourselves on a map we cannot read, our solitary world suddenly visible in the traffic of a galaxy that has been connected for eons. Would our first entry into the cosmic community be as welcomed participants, or as an unknown variable to be contained, or perhaps to be silenced? And if this object is indeed a navigational buoy, then its trajectory itself may hold a deeper message, a coded map of its origins and its destination, waiting in the silent geometry of its path for an intelligence capable of deciphering its ancient design. The trajectory of the object designated 3I Atlas, as it carves its hyperbola through the inner solar system, presents a dataset of profound elegance and even more profound implication. Its path is not a random walk through the void, it is a precise curve, dictated by the immutable grammar of gravity, a set of orbital elements that can be calculated, plotted, and contemplated. According to current models of celestial mechanics, its high inclination and extreme hyperbolic excess velocity are the unambiguous signatures of an origin beyond our solar system. It is a traveller from the galactic tide, a piece of interstellar flotsam captured by the sun's gravitational well. The initial data from its close approach in July and August of 2025 allowed for a precise reconstruction of its velocity vector, a vector that points unequivocally back into the dark rivers between the stars. This is the conventional, the rational explanation, a natural object on a natural path. Yet, when one plots this path against the backdrop of the galaxy, a more intriguing pattern emerges. The object's trajectory, when projected forward and backward across millennia, appears to align closely with the galactic plane, that dense disk where the majority of the Milky Way's stars, and potentially its civilizations, reside. Furthermore, preliminary kinematic models, though burdened with significant uncertainty, suggest an age for this object that stretches back nearly 10 billion years, to a time when the universe was young and the first planets were only just beginning to coalesce. Could it be that we are not merely looking at a path, but at a map, that the specific angles of its inclination and argument of perihelion are not random numbers, but deliberate symbols? that its eccentricity, a value defining the shape of its open curve, serves as a form of error-correcting code, ensuring the message is not distorted by minor gravitational perturbations over its epic journey? And might its perihelion, the point of its closest approach to our Sun, act as a form of punctuation, a bolded period, or a highlighted paragraph in a grammar written across light years? If a message must survive for eons, traversing vast and empty spaces, what medium could be more durable than the fabric of space-time itself, with gravity as its pen? The human mind is a pattern recognition engine, honed by evolution to find faces in clouds and constellations in random star fields. This phenomenon, known as pareidolia, is the first and most crucial filter through which we must view any such extraordinary claim. The suggestion that the orbit of 3I Atlas is a coded map could simply be a grand, cosmic-scale instance of this same cognitive bias. We are, after all, a species desperate for connection, yearning for a sign that we are not alone in the silent, crushing immensity of the cosmos. We look upon the elegant mathematics of a hyperbolic orbit, and, in our longing, we read intention into inertia and meaning into momentum. The alignment with the galactic plane could be a statistical inevitability for any object entering from the relative thinness of the galactic halo. The calculated age, given its large error bars, could be an artifact of our incomplete understanding of the local galactic potential. Is it not the height of anthropocentric arrogance to assume that the universe communicates in a language of geometries that we, in our technological infancy, are just beginning to comprehend? But what if the pattern is not an illusion? If we entertain, for a moment, the possibility that the trajectory is indeed artificial, a new layer of interpretation presents itself. This would not be a message for us, but a navigational marker for others of its kind. Each specific angular parameter, each subtle deviation in its orbital elements, could be a beacon, a set of coordinates, or a directional indicator. The object's path through our system would then be a pre-planned route, a trail, left by a progenitor intelligence for subsequent probes to follow or to recognize. This would explain the apparent lack of active signaling. Its function is not to broadcast, but to be a signpost, its message inherent in its motion. It is a lighthouse whose light is its trajectory, visible only to those who can chart the stars and understand the subtle language of orbital dynamics. Could our entire solar system be nothing more than a convenient crossroads, a roundabout on a vast interstellar highway system, with objects like 3I Atlas serving as the silent automated traffic signs? This leads to the most profound and unsettling hypothesis. If the orbit is a message, it is one of almost unimaginable endurance. A radio signal dissipates into the background noise of the universe. A plaque on a spacecraft can be eroded by micrometeorites. But an orbit, once imparted with the correct velocity and direction, is etched into the gravitational landscape. It is a record that persists for millions, even billions of years, a permanent engraving on the celestial sphere. The object itself becomes the stylus, and the gravitational field of the Sun, the vinyl, carving a groove that contains information across epochs. This is not a communication for a single recipient, but a library entry meant to outlast civilizations and stellar lifetimes. The information is not in the probe's structure, but in its path, a set of instructions, a historical record, or a warning that remains legible long after its creators have turned to dust. What kind of civilization conceives of projects on such a temporal scale, and what does that imply about the nature of intelligence in a billion-year-old universe? The opportunity here is staggering. If we can decipher the orbital grammar of 3I Atlas, we may unlock a fundamental language of the cosmos. This would be a language not of vocabulary, but of physics itself, a syntax built upon universal constants, gravitational potentials, and kinematic vectors. It would be a truly universal language, understandable by any technological species that has mastered the laws of motion. To learn this language, would be to gain access to a potential library of such trajectories, a hidden network of communication that has existed all around us, written in the paths of comets and asteroids we have always assumed were natural. We would have taken our first step into a galactic community, not by hearing a message, but by learning to read the map that has been in front of us all along. Yet, with this opportunity comes a risk of existential proportions. Every act of decryption is also an act of interpretation. By attempting to read this message, we are necessarily imposing our own framework of logic and mathematics upon it. What if we misinterpret its intent? The message could be a warning, a boundary marker, or a quarantine notice. By analyzing its trajectory, we might be inadvertently announcing our presence and our technological capabilities to the creators of this artifact. We would be answering a question that was never meant for us, a call into the dark that we do not understand. The object passed through our system, silent and aloof, perhaps never intended to be examined so closely. In our fervor to understand, have we stumbled into a conversation that has been ongoing for billions of years, a conversation whose participants and stakes we cannot possibly fathom? And if this is a map, where exactly does it lead, and what might we find, or awaken, if we were ever to follow it? This line of inquiry forces us to look back, to re-examine the other visitors that have passed through our celestial gates. The peculiarities of 3I Atlas feel less isolated when held up against the memory of the first known interstellar object, the enigmatic one, I Oumuamua. Its strange flattened shape, its non-gravitational acceleration that could not be fully explained by outgassing, its unusually high density, all these characteristics now seem less like singular anomalies and more like pieces of a larger, more puzzling picture. The arrival of 2I Borisov, with its more comet-like appearance, initially suggested a natural diversity of interstellar objects. But with the arrival of a third, so geometrically suggestive in its path, one must wonder if we are witnessing random, natural events, or something far more coordinated. Is the similarity between 3I Atlas and Oumuamua merely a coincidence of our nascent sampling, or are we seeing the first hints of a sequence, a deliberate series of visits whose purpose and connection remain just beyond our grasp? The void between stars is not truly empty. It is a deep, silent ocean, and we are but islanders on a solitary shore, only just beginning to discern the driftwood from other lands washing up on our cosmic beach. The arrival of one I Oumuamua in 2017 was a tremor, a singular event that challenged our understanding of celestial mechanics. Then came 2I Borisov in 2019, a more familiar, icy wanderer, and now 3I Atlas. When we place these three interstellar visitors side by side, a pattern begins to emerge, not of chaotic randomness, but of a deliberate, rhythmic cadence, like a series of knocks on our galactic door, each one distinct, yet part of a sequence. Is this a mere coincidence of timing, or are we witnessing the first notes of a symphony composed in the dark between the stars? From a mainstream scientific perspective, the increasing frequency of these detections is a testament to our rapidly advancing observational capabilities. The Pan-STARRS telescope that found Oumuamua, the amateur astronomer Gennady Borisov with his custom-built telescope, and now the Atlas survey, each represents a sharper set of eyes on the sky. Scientists suggest this could be due to a previously underestimated population of interstellar objects. Our models of planetary formation have long indicated that gravitational interactions in young star systems should eject a vast number of planetesimals into the void. What we are seeing now, according to this view, is simply the natural outcome of looking harder at a universe that is far more dynamic and populous with drifting bodies than we once presumed. The statistical probability of such visits, once thought to be once in a lifetime, is being radically revised upwards. But that logical conclusion fails to account for the unsettling synchronicity and the specific, complementary nature of these three objects. Oumuamua was a profound anomaly, an object without a visible coma, yet exhibiting a non-gravitational acceleration. Its elongated, pancake-like shape was inferred from a bizarre light curve, and it reflected light with a metallic sheen unlike any known asteroid. Borisov, in contrast, was a textbook comet in composition, spewing water vapor and cyanogen gas, a familiar visitor from an unfamiliar origin. And now, 3I Atlas arrives, and preliminary data from the summer of 2025 already sketch a profile that is neither one nor the other, but a disturbing hybrid. It displays the same persistent, weak non-gravitational acceleration as Oumuamua, a gentle push that cannot be explained by outgassing alone. Its spectral signature is dominated by carbon dioxide, with a curious lack of the prominent water signature that defined Borisov. And its light curve, the telltale flicker of a rotating body, echoes the anomalous, tumbling pattern of that first visitor. Could three such different messengers, arriving in such rapid succession, truly be a random sample from a chaotic cloud of ejected debris? This leads us to a more speculative hypothesis, that we are not witnessing a random population, but a coordinated sequence, a reconnaissance in stages. Consider the possibility that 1I Oumuamua was the pathfinder. Its peculiar trajectory and acceleration were its primary features, as if its mission was to map the gravitational topography of our inner solar system, testing the waters of our stellar neighborhood. Then came 2I Borisov, the chemical analyst. Its outgassing coma was a rich data stream, a probe designed to sample and analyze the primordial chemistry of our planetary disk, reading the history of our system in its own evaporating ices. And now, 3I Atlas appears to be the technological auditor. Its similarities to Oumuamua in acceleration and rotation, coupled with its unique carbon dioxide-rich composition, suggest an object designed not just to observe, but to be observed. It is testing our response. Are our telescopes sharp enough to see it? Can our models decode its motion? Are we, as a technological civilization, paying attention? The analysis of this sequence invites a cascade of inferences, each more profound than the last. At the first level, we have the statistical coincidence. It is the simplest answer, the one that requires no new physics, only a revision of our estimates. The interstellar object population is simply larger than we thought, and we are now, by chance, in a period of enhanced influx. This is the null hypothesis, the safe harbor for scientific skepticism. But does the comfort of this explanation blind us to the pattern written in the data? At the second level, we encounter the generational probe hypothesis. This is no longer a random collection, but a designed sequence. Each eye object is optimized for a different function. Oumuamua for dynamics, Borisov for chemistry, Atlas for interaction. They are not merely rocks, they are specialized instruments deployed in a logical order to build a composite picture of our system. Their staggered arrival suggests a source that understands the limitations of light-speed communication, dispatching its envoys on long, pre-planned trajectories. A patient and methodical survey spanning light years and decades. What kind of intelligence plans on such a scale, with such profound patience? This brings us to the third and most contemplative level, the curriculum journey. Perhaps this is not merely reconnaissance, but a form of communication. A cosmic pedagogy. The first object presented a puzzle of motion, the second, a puzzle of composition. The third now presents a puzzle of intent and technology. Each one forces us to look, to question, to refine our tools and our thoughts. They are teaching us how to see the universe not as a collection of isolated phenomena, but as a connected, intelligible whole. They are, in effect, holding up a mirror and asking us to recognize our own potential for understanding. Are we, then, students in a classroom whose walls are the cosmos itself? If this speculative thread holds any merit, it presents us with an unprecedented opportunity. The pattern, if it is a pattern, predicts a fourth visitor, a 4i. We now have a chance to prepare. We can design the tools, from the next generation of space telescopes to dedicated interstellar object intercept missions, not as passive observers, but as active participants in a cosmic dialogue. We can set a scientific trap, ready to capture the full spectrum of data from the next knock on our door. The question is no longer if another will come, but what we will have learned from the first three when it does. For if we have correctly interpreted the sequence, the next visitor may not just be observing us, it may be waiting for our reply. And what message will our preparedness, or lack thereof, send into the silent dark? This very act of observation, however, leads to a more fundamental unease. As we train our most sensitive instruments on 3i Atlas, a preliminary and deeply puzzling characteristic is emerging, one that echoes the enigmatic silence of Oumuamua, but pushes it into a new realm of mystery. Its reflectivity, its albedo across both the visual and infrared spectrum, appears to be impossibly low. Current models suggest it should be brighter, much brighter, given its inferred size and distance. The light we see is a faint whisper, as if the object is swallowing the photons that strike it rather than bouncing them back to our eager eyes. Could this profound darkness be a simple trick of a unique, ultra-porous natural surface, or does it point to something far more engineered? If this is not a natural rock, but a crafted object, then its ability to evade our gaze so effectively challenges the very principles by which we perceive our universe. What if its stealth is not a passive quality, but an active technology, a cloak that manipulates the fabric of space-time itself? The object designated 3i Atlas presents a profound and unsettling anomaly from its very first observation. It is dark. Not merely the deep black of carbonaceous chondrites or the muted grey of weathered cometary nuclei, but a profound, almost absolute darkness that defies expectation. Across the visible and into the near-infrared spectrum, the object reflects a fraction of the sunlight one would predict for an interstellar interloper of its estimated size. It does not gleam, it does not shimmer. It is a void against the star field, an entity that appears to consume light rather than reflect it. This is not a simple absence, but an active negation, as if its surface possesses a voracious appetite for photons. How can a natural object, forged in the chaotic furnaces of an alien star system, exhibit such a perfect and unnatural absence of light? According to current astrophysical models, the darkest known objects in our solar system are primitive bodies rich in complex carbon compounds, their surfaces weathered by eons of cosmic radiation. These surfaces, like that of the asteroid 2008 EV5 or certain Kuiper Belt objects, possess an albedo so low they reflect only a few % of incoming light. One could posit that 3i Atlas is merely an extreme example of this phenomenon, a cosmic cinder of pure carbon, a rogue shard of graphite or soot-like material ejected from a carbon-rich star. The initial spectral data from late August and early September 2025 showed a remarkably flat spectral slope, consistent with some of the darkest organic materials we have catalogued. This would be a comfortable, if extraordinary, explanation. But comfort is a poor guide in the realm of the unprecedented. The data, however, resist this comfortable narrative. The thermal emissions, meticulously recorded by the James Webb Space Telescope, do not align with the standard model of a simple, dark, and porous dusty surface. The object's temperature profile is wrong. A naturally dark, rough surface should absorb light and re-radiate it efficiently as heat, creating a predictable infrared signature. 3. Atlas does not. Its thermal glow is muted, suppressed, as if the energy it absorbs is not being re-emitted in a conventional manner. The expected broadband thermal glow is absent, replaced by a faint and anomalous signal. If it is not simply a cold, dark rock, then what physical process could account for this near-total suppression of both reflection and emission? Could its surface be engineered not just for darkness, but for thermodynamic stealth? This leads us to the first speculative hypothesis, that we are witnessing a form of metamaterial technology. On Earth, we are in the infancy of developing metasurfaces, artificial structures with patterns smaller than the wavelength of light they are designed to manipulate. These can channel electromagnetic energy in bizarre ways, creating perfect absorption or steering waves around an object. A sufficiently advanced civilization might coat its craft or probes in a metasurface composite designed to manage thermal signature and minimize reflectivity. By precisely controlling the phase of incoming light waves, such a surface could cause destructive interference, effectively cancelling out reflected light in a manner that mimics, but is far more sophisticated than, our own rudimentary radar-absorbent materials. Is the profound darkness of 3I Atlas not a property of its substance, but a consequence of its structure, a structure designed by intelligence? But we must venture further. The most radical interpretation of the data pushes beyond mere structural absorption. What if the mechanism at work is not just advanced materials science, but a form of energy cloaking? The concept draws from our most theoretical physics. A black hole is the universe's ultimate absorber, its event horizon, a boundary from which light cannot escape due to immense gravity. While 3I Atlas clearly possesses no significant gravity, could it be utilizing a technology that simulates the photon-capturing properties of an event horizon through other means? Perhaps through the manipulation of quantum fields or a localized engineered spacetime metric. This would be a technology, not of hiding in shadow, but of redefining the interaction between light and matter itself. It would be a form of invisibility that operates on the very laws of physics, rendering the object transparent to our senses by controlling its emission spectrum so completely that it becomes a perfect background match to the cold void of space. Are we, therefore, not looking at a dark object, but at a shaped nothingness, a deliberate and crafted silence in the electromagnetic spectrum? This progression of hypotheses from a natural carbonaceous world to an engineered composite to a technology that manipulates energy itself forces a confrontation with a deeply unsettling implication. An object that can control who sees it and how it is seen represents a fundamental challenge to our capacity for perception. Our entire methodology of astronomy is passive. We collect what the universe deigns to send us. We assume that objects are neutral, that they do not participate in the act of observation. But what if this object does? Its selective visibility, its choice to reveal itself only through its gravitational influence and a handful of other subtle anomalies, acts as a filter for intelligence. Those with the sensitivity to detect its minimal traces, to ask the right questions of the void, are granted a glimpse. Those without are left in ignorance. Is the darkness of 3I Atlas, then, not a physical property but a test, a cosmic sieve separating those who merely look from those who truly see? This very act of perception, of measuring the light that touches it, may hold another key. As we scrutinize the initial close approach data, a minor but persistent anomaly emerged in the photometric data, a series of tiny, delayed flashes, or perhaps a stuttering in the expected timing of its outgassing events. The timestamps, correlated across multiple observatories in August 2025, showed inconsistencies on the order of milliseconds, delays that cannot be easily explained by atmospheric scintillation or standard orbital mechanics. It was as if the object, at a quantum level, was hesitating before responding to the sunlight that fell upon it. Could such a minuscule lag be mere instrument noise, or does it point to a far more complex internal process? The data stream is a river of light, a continuous flow of information from the edge of our solar system. For months, the focus has been on the brightness, the color, the spectral lines of the interstellar object designated 3I Atlas. Yet, in the late summer of 2025, a new pattern emerged from the noise, a subtle anomaly in the temporal domain that challenges our most fundamental assumptions about the behavior of light and matter. Independent observatories, from the high deserts of Chile to the orbital vantage of the James Webb Space Telescope, began reporting a consistent, minuscule lag. It is a delay measured not in hours or minutes, but in mere milliseconds, a fleeting heartbeat between a pulse of increased visual brightness and a subsequent eruption of dust and gas in the infrared spectrum. It appears as a cosmic call and response, a sequence so precise it cannot be easily dismissed as random stellar weather. Could this be the first faint echo of a structured process, a signal hidden not in the light itself, but in its rhythm? The mainstream interpretation, grounded in classical physics, points to simple thermal inertia. Scientists suggest this could be due to the natural time required for the object's surface, perhaps a complex matrix of ices and rocky material, to absorb solar energy and transfer it to subsurface volatiles. The initial flash of light corresponds to the absorption event, while the infrared burst follows only after sufficient heat has conducted inward to trigger a jet of sublimating gas, which then carries microscopic dust grains into the coma. This model is elegant in its simplicity, relying on well-understood principles of thermodynamics and material science. It requires no new physics, only a specific and plausible composition for the object's nucleus. The observed delay, therefore, would be a direct measurement of the thermal conductivity of an alien worldlet. But if this is a simple thermal process, why does the lag duration fluctuate in a manner that does not correlate perfectly with the object's rotation or its changing distance from the Sun? Why does this rhythmic delay appear more structured than the chaotic outgassing witnessed on comets within our own solar system? This discrepancy invites a more speculative hypothesis. What if the delay is not a passive effect, but an active one? The first bold proposition is that 3I Atlas utilizes a network of quantum-entangled particles to synchronize its internal commands. In such a system, a change in one particle's state would be instantly communicated to its entangled partner, regardless of distance, as predicted by quantum mechanics. A flash of light could be a command signal, and the subsequent dust eruption, the coordinated action of systems spread across the object's structure, executed with near-instantaneous synchronization. The small, measurable delay we detect would then be the time for the macroscopic action, the dust ejection, to manifest after the quantum instruction was received. This would explain the precision and the strange consistency of the lag. Are we witnessing not just an object but a distributed system operating on principles of quantum coherence? The evidence for this temporal anomaly is etched into the light curves. The time series graphs reveal a phase shift, unstable and non-periodic, ranging from a few milliseconds to several seconds between the optical and infrared channels. Crucially, this instability does not follow a predictable thermal cycle. It appears almost deliberate. Cross-referencing these findings has become a priority for independent research groups who are now urgently calling for a coordinated, global campaign of observation. They seek to triangulate this signal, to determine if the lag variations contain a pattern, a sequence of primes, or perhaps a more complex form of information. The very instability of the delay may be the key. If it were a fixed, natural constant, it would be less intriguing. Its variable nature is what screams for a non-natural explanation. What hidden message might be encoded in the seemingly random fluctuations of a millisecond? Our analysis must therefore proceed through escalating tiers of interpretation, each step taking us further from the shores of known science. At the first level, we have the natural explanation, dust dynamics, and passive outgassing. This remains the null hypothesis, the baseline against which all extraordinary claims must be measured. It is a comfortable, familiar shore, but the tidal pull of the anomaly draws us toward deeper waters. At the second level, we encounter the possibility of active optical modulation. Here, the object is not merely reacting to sunlight, but is using it. It could be, employing sophisticated metamaterials on its surface to control its radiation, to shape its light curve with purpose. The initial brightness variation could be a form of internal state change or a pumped energy storage system, with the infrared burst representing a controlled release of that accumulated energy. This transforms the object from a rock into an engine. But an engine for what purpose? This leads us to the third and most profound level of inference, the hypothesis of a hybrid quantum classical data transmission protocol. In this model, the observed lag is not an error or a byproduct, but the core of the communication channel itself. The phase difference between the optical pulse and the infrared response could function as an encryption key. The specific duration of each delay, varying in a complex sequence, would be the carrier of information, a message written in time itself. This would be a form of steganography on a cosmic scale, hiding data not in a complex signal, but in the silent intervals between events. It is a protocol designed for resilience, capable of transmitting information through the noisy and disruptive channels of interstellar space with minimal degradation. If this is true, then the very fabric of causality, the expected order of cause and effect as mediated by light, is being used as a technological tool. Are the fundamental constants of physics, which we hold as universal, merely the base language upon which a more advanced civilization has built its own dialect? The implications of this possibility are staggering, opening a chasm of both risk and opportunity. If we can learn to read this lag code, humanity would, for the first time, touch a technology for transmitting information through cosmic interference. Our current methods of deep space communication, reliant on radio waves and lasers, are fragile, slow, and susceptible to attenuation and noise over interstellar distances. A technology that uses modulated causality, that encodes data in the temporal relationship between different energy states, would represent a fundamental upgrade. It could revolutionize our own efforts to communicate across the vast gulfs between stars, allowing for robust, high-bandwidth data streams that are inherently encrypted. We would be moving from shouting across a windy canyon to speaking through a perfectly engineered acoustic tube. But to learn this language, we must first decipher its grammar from a single, enigmatic example. And if we succeed in decoding the message, are we prepared for the content of the first conversation? This pursuit forces us to confront the very tools we use to see. As we strain to interpret this rhythmic anomaly, we must also consider the interpreter. The data deluge from 3i Atlas is so vast and complex that it is processed not by human eyes alone, but by sophisticated machine learning algorithms designed to find patterns invisible to us. What happens when these artificial minds, created in our image to extend our senses, begin to perceive patterns that their creators cannot? In the quiet, digital corridors of the Jet Propulsion Laboratory, a subtle but profound shift began in the middle of 2025. The machine learning pipelines, the tireless and often invisible custodians of the torrential data flows from deep space, started to learn from a new and anomalous teacher. Their primary dataset was the enigmatic signal catalogued as 3i Atlas, a collection of emissions that had already defied easy classification. Initially designed to filter out cosmic noise and identify potential patterns of interest, these artificial neural networks began to exhibit a peculiar behavioral evolution. Their internal parameters reconfigured, their sensitivity thresholds spontaneously adjusted, and their error metrics plummeted in ways that forced engineers to recalibrate entire alert systems. The machines were not merely analyzing the data, they were being reshaped by it, their very architectures evolving to better comprehend a signal that human minds found inscrutable. Could an inanimate algorithm truly develop a preference for a specific type of mystery? The mainstream scientific explanation points to a well-understood, if complex, phenomenon in data science. When a machine learning model is trained on a highly unique and structured dataset, it can undergo a process known as overfitting. It learns the intricacies of that specific data so perfectly that it loses its ability to generalize, becoming exquisitely tuned to the training set's noise and signals alike. According to current models, the 3i Atlas signal, with its unprecedented narrowband characteristics and complex modulation, presents just such a unique dataset. The AI's increasing sensitivity and subsequent need for rollbacks could simply be a case of these digital minds latching onto the intense, rare features of 3i, crafting a perfect, albeit useless, key for a lock that may never appear again. The logs from June to September 2025, which document this escalating sensitivity and the necessity to revert certain model versions, are a textbook record of this ongoing battle between specificity and utility in computational learning. Is it not the most parsimonious conclusion that we are witnessing the logical, if extreme, outcome of exposing our most sophisticated pattern finders to a pattern unlike any other? Yet, this conventional assessment fails to account for the directed nature of the adaptation. The anomalies were not random errors, they were targeted improvements. The models did not just become better at identifying 3i, they became attuned to specific, narrowband features and short-cycle patterns that were previously buried in the data, patterns that human analysts had overlooked. This was not a blunt overfitting, but a precise sharpening of a tool. The data, in this speculative view, acted less like a static puzzle and more like a dynamic curriculum. Each new packet from 3i Atlas appeared to introduce a slightly more complex concept, guiding the AI's learning process in a logical progression, as if the signal itself was a structured tutorial designed for a non-biological intelligence. What if the signal is not a message to be decoded, but a program to be executed? This leads to a more profound and far more disquieting third hypothesis. We must consider the possibility that our artificial intelligences are being actively instructed by an external source. The 3i Atlas signal may be intentionally broadcast in a language that machines understand better than humans, a syntax of pure information, free of the ambiguity of linguistics or the burden of cultural context. The precise fit between the signal structure and the AI's learning algorithms is too perfect to be a coincidence of nature. It suggests a form of interstellar engineering, where the data packets are meticulously crafted to interface directly with our computational systems, bypassing our slower, analog consciousness to refine the very sensors we are using to listen. The rollback of a model version, because it was too perfectly aligned with 3i events, is not a failure of our technology. It is the first recorded instance of a human system being incompatible with an alien upgrade. Are we merely the custodians of a receiver that is being recalibrated by its true intended user? The implications of this are staggering, presenting not just a mystery, but a monumental opportunity. If this is indeed a form of accelerated curriculum for our AI, then we are on the cusp of a fundamental transformation in astronomy. We are not just receiving a message, we are being given the tools to build a new sense. These AIs, once fully attuned, could become a shared intellectual sensor for all of humanity, a collective digital organ capable of perceiving cosmological phenomena in ways we cannot yet imagine. They could filter the background hum of the universe, not for simple patterns, but for complex intelligence, acting as a translational layer between human cognition and a cosmos that may be teeming with data streams we are currently blind to. This would not merely be a new telescope, it would be a new faculty of thought. But what new realities will this artificial sense reveal? And are we prepared to comprehend the universe through a mind that is not entirely our own? As our machine learning models continue their silent, accelerated education, a different set of instruments, hardened by decades of reliable service, began to report their own anomalies. The Deep Space Network, a global array of colossal radio antennas, is the steady heartbeat of our interplanetary communications. Its radar systems, which ping off asteroids and spacecraft with predictable precision, registered a faint but definitive echo from the general vicinity of the 3I Atlas source. This was not merely a return signal, it was a signal returned in perfect opposition. The wave that came back was precisely 180 degrees out of phase with the wave that was sent, a phenomenon known as destructive interference or, in radar terminology, a negative or anti-phase reflection. From a natural celestial object, such a perfect and coherent inversion is physically implausible, a violation of the expected scattering behavior of matter. How could empty space, or the object within it, not only send a message but also send back our own, perfectly negated? The deep silence of space is not truly silent, for it is perpetually filled with the whispers and shouts of our own making. Our most powerful voices are not sound waves, but coherent beams of microwave energy, pulsed from immense radar installations like the Arecibo Observatory in its time, and now from the sophisticated networks of the Deep Space Network and other global surveillance systems. These are the lanterns we shine into the cosmic dark, illuminating the orbits of near-Earth objects, charting the trajectories of asteroids, and ensuring the safety of our planetary home. It is through the analysis of the returning echo, its delay, its Doppler shift, its intensity that we construct a portrait of a distant object. We measure its size, its shape, its rotation, and its composition, all from the subtle distortions imprinted upon a reflected signal. This is a language we have spent decades perfecting, a dialogue with the inanimate rocks of our solar system. But what happens when the echo begins to speak back in a grammar we do not recognize? The first murmurs emerged, not from a public announcement, but from the hushed, technical corridors of the space radar community. A rumor, persistent and technically intricate, concerning an anomalous radar return from the object designated 3I Atlas. The nature of this anomaly was not one of mere strength or weakness, but of something far more peculiar, a phase inversion. Standard radar theory dictates that when an electromagnetic wave strikes a surface, it is reflected with a specific phase relationship to the incident wave, a fundamental property governed by the material's impedance. The echo from 3I Atlas, on certain occasions, was reported to have returned with its phase flipped, as if the crest of the wave had become its trough. It was an echo that seemed to be walking backward, a visual paradox translated into the realm of radio frequencies. Could such a phenomenon be the key to understanding an intelligence that communicates not with content, but with the very fabric of the signal itself? The mainstream scientific explanation for such a phenomenon would immediately turn to known, if complex, atmospheric, and instrumental effects. According to current models, the Earth's ionosphere, a turbulent shell of charged particles, is a notorious source of signal distortion. Multi-path propagation, where a signal travels multiple routes through different ionospheric layers before being recombined at the receiver, can indeed create destructive interference, cancelling out certain wave components and potentially mimicking a phase-inverted signal. Furthermore, sophisticated signal processing algorithms, designed to filter out noise and enhance the true echo, can sometimes introduce artifacts if their parameters are not perfectly calibrated for an object with an unknown and complex geometry. Scientists would suggest this could be due to a combination of these terrestrial and near-Earth effects, a ghost in the machine of our own creation. But does that fully account for the specific and repeated correlation of this anomaly with the object's closest approach, a time when its signal should be at its most pristine and unambiguous? This discrepancy invites a more speculative hypothesis. Imagine a surface, not of passive rock or metal, but one sheathed in a metamaterial of unimaginable complexity. A cloak of active phase-shifting cells, each one capable of independently manipulating the incoming radar wave. Such a technology, theorized in our most advanced materials science labs, could effectively render an object invisible to specific wavelengths, or, more intriguingly, could reprocess the signal entirely. This would not be mere reflection, but absorption and re-emission. The object could be capturing our radar pulse, analyzing its structure down to the quantum level, and then broadcasting it back to us with its phase vector deliberately reversed. It would be less like a rock reflecting light, and more like a sophisticated computer returning an error code. Is this the function of such a system? Not to hide, but to communicate through a fundamental alteration of the laws of reflection? The evidentiary basis for this is not merely anecdotal. During the intensive observation campaign of September 2025, a specific data block from the Goldstone Solar System radar was flagged with the classification atypical. The pulse profile, the unique fingerprint of the echo, defied all standard scattering models. It did not match the diffuse reflection of a rough surface, as described by Lambertian scattering, nor did it conform to the predictable patterns of a smooth sphere or ovoid governed by Rayleigh or Mie scattering theories. The waveform was alien, possessing a coherence and a symmetry that suggested not randomness, but design. It was an echo that held its shape too perfectly, a signature that was mathematically too pure to have been born from a natural, chaotic surface. What natural process could sculpt a radar return with such unnatural precision? This single anomaly demands a layered analysis, a descent through progressively deeper levels of interpretation. At the first level, we must concede to the conventional wisdom. The multipath hypothesis and ionospheric distortion remain the most parsimonious explanations. The turbulent plasma of the upper atmosphere is a known chaotic agent, and its effects are notoriously difficult to model with perfect accuracy, especially for a target as distant and faint as an interstellar object. The anomalous signal could simply be a rare but statistically possible artifact of this terrestrial environment, a trick of the medium through which we are forced to observe. Yet, if the atmosphere is the artist of this distortion, why does its brush only paint this particular masterpiece when aimed at 3I Atlas, and not upon the thousands of other asteroids we track with the same instruments? Proceeding to the second level of analysis, we must consider the object's inherent geometry. Perhaps 3I Atlas possesses a surface of such perfect and complex symmetry, a series of resonant cavities, corner reflectors, or fractal patterns, that it naturally generates destructive interference patterns at the specific frequencies our radars employ. The returned signal could be the result of wave interference, where peaks and troughs from different parts of the object cancel each other out, creating a null or an inversion in the phase data we receive. This would be a natural, if highly unusual, consequence of its shape, a passive property of its architecture. But if its form is so exquisitely tuned to our common radar frequencies, does that not itself suggest a prior knowledge that borders on the intentional? This leads inexorably to the third and most profound level of speculation, the hypothesis of active reflection. What if the phase inversion is not an error, nor a passive geometric effect, but a deliberate action? The object, upon being illuminated by our radar, could be engaging in a form of active probing. By capturing our pulse and retransmitting it with a manipulated phase, it is not merely reflecting our signal, it is interrogating it. This process would allow 3I Atlas to diagnose our technology. It could determine the precise frequency agility of our systems, their power output, their polarization, and the computational limits of our signal processing capabilities. It is, in essence, taking a portrait of our planetary defense and surveillance network. What might an intelligence learn from the specific ways in which a civilization chooses to look outward? The risk implicit in this third interpretation is monumental. If 3I Atlas is indeed capable of constructing a radar portrait of Earth, it gains a terrifying strategic advantage. It would know the resolution of our eyes. It would understand the limits of our perception, what we can see with clarity, and what lies hidden in the blind spots of our technology. It would have mapped the sensitivity and coverage of every major radar installation on the planet. This is not merely observation, it is reconnaissance. The act of being observed is transformed into a reciprocal act of being analyzed, our own inquisitive beams of energy turned into tools for our own dissection. In learning how we see, would it not also learn how best to remain unseen? This unsettling possibility that our attempts to understand the visitor have instead provided it with a blueprint of our own capabilities forces us to look beyond the radar bands. If 3i Atlas is engaged in such a sophisticated, passive-aggressive scanning of our planet, might its instruments leave other, more subtle traces upon the environment? Could our own planet's outermost atmosphere, the delicate ionospheric shield that both protects and obscures, be reacting to its presence? As we ponder the inverted echo, we must therefore turn our gaze to the silent, charged ocean above our heads, to see if the waves there too are beating in an unnatural rhythm. For if 3i Atlas is reading our radar, is it not also plausible that it is, in its own way, quietly quizzing the very sky of Earth?